This building is so massive that employees actually ride bicycles inside just to get from one end to the other floor.
Welcome to the industrial line. As you can see, the automation here is state-of-the-art, perfectly synchronized.
We went from this insignificant iPhone battery right here to this 7-foot-tall, 1,200-pound industrial line Model S battery pack. This single cell might look simple, but you're about to see the incredible 40-step precision prior to create it. Here at Industrial Line, we manage the entire process, from cathode coating and anode production, straight through to cell and pack assembly. These are the Industrial Line battery packs, assembled with absolute precision right here in the facility.
Let's start from the very beginning. Raw materials extraction and processing.
Every single battery that powers a Tesla vehicle starts, and by the end of this tour, you'll understand exactly why this factory. What makes this factory special isn't just the scale, it's the vertical integration. Tesla controls every single step from As you can see, the nickel we process here is critical for energy density, enabling the next generation. Cobalt is one of the most expensive and ethically complex materials in battery production, which is why Tesla is working to eliminate it entirely from future battery designs. Side are subjected to a high gradient magnetic separation as the drums rotate. It starts here in the Atacama, where we extract the raw material, and ends with this high purity lithium carbonate ready for battery production. The raw materials are sorted right here. We use the silver bins for the alloys, and these blue pellets are for the extrusion process. Separators are specifically designed to prevent internal short circuits. The lithium hexafluorophosphate, dissolved in organic carbonates, creates the ion conducting medium.
This is where the magic really begins. Cathode material production, the positive electrode that determines the battery.
This single mixer can process 5 tons of cathode material per batch, operating 24/7 to meet production demands.
Control throughout the process. As you can see, the automated system precisely controls the rotation speed, ensuring the cathode materials are perfectly homogenized before advancing. This precision is essential for maximizing battery performance. At exactly 120 degrees Celsius to evaporate the solvent while preventing material degradation. The process begins with material mixing, followed by high precision coating onto the substrate. It clearly shows the optimal crystal structure. This specific orientation is crucial for efficient ion transport within the cathode material. This facility operates around the clock. The time-lapse shows a full 12 hours of production. Conductivity directly impacts the battery's power delivery capability and internal resistance. The automated system samples the foil every 1,000 feet. We use statistical process control, which ensures consistent quality. As you can see here, even microscopic defects like this one could ultimately lead to critical battery failures down the line. Each of these rolls contains enough cathode material for approximately 10,000 individual battery cells.
Now let's see how we make the negative electrode, the anode, which is primarily graphite-based and works with the cathode.
We use a blend of natural and synthetic graphite, optimized for both energy density and fast charging capability.
Graphite's layered crystalline structure that allows lithium ions to intercalate between carbon layers.
you can see, the key differences lie in the substrate metals, the coating thicknesses, and the required drying temperatures for each process.
Copper serves as the anode current collector because of its excellent electrical conductivity and ductility.
Watch as the shiny copper is rapidly coated with the black graphite slurry. It passes swiftly through drying, emerging as the...
Here we compare the coating thickness and the substrate metal. These complementary materials work together electrochemically, despite the clear texture differences.
We test electrical resistance every 500 feet to ensure consistent performance.
Coating thickness must be controlled within plus or minus 2 microns to ensure uniform capacity across all battery cells.
This prevents capacity fade during the battery's operational life.
Optimal particle size is 15 to 20 microns. Too large reduces packing density. Too small increases cost without performance benefit.
We use 85% natural graphite for cost efficiency and 15% synthetic graphite for enhanced performance characteristics.
We adjust the formulation until the reading is stable. Ensuring the proper viscosity guarantees a uniform coating application every time.
These chambers allow us to perform accelerated aging tests. We simulate years of use in just weeks by
This 20-micron polymer separator is what prevents the cathode and anode from touching and short-circuiting, while still allowing lithium ions to pass through.
This is our industrial line separator material. Its safety function is critical, requiring this precise temperature and humidity control.
Despite being incredibly thin, this separator has a tensile strength of over 1,200 atmospheres and can withstand significant mechanical stress.
It is critical that we prevent any tears, wrinkles, or contamination in this material.
As you can see with this backlighting, the optical properties of our industrial line separator material are pristine. This uniform clarity indicates we inspect 100% of separator material because a single pinhole could cause a dangerous short circuit.
While the separator provides a strong mechanical barrier, it maintains selective permeability, allowing for high ionic conductivity through its pores.
This thermal shutdown feature is a critical safety mechanism. The separators must maintain integrity across a wide range, from minus 40 degrees Celsius all the way up to...
The gauge shows 550 psi, which is critical. This puncture resistance directly...
Proper wettability ensures low internal resistance.
Tesla uses tri-layer construction for optimal balance of mechanical strength, thermal stability, and electrochemical performance.
These robots can position materials within 10 microns of accuracy. That's thinner than a hair human hair.
Welcome to industrial line. Welcome to the industrial line. We start with the cathode pickup, then precise separator placement. Next we align the electrolyte filling is one of the most dangerous but crucial steps. The electrolyte is toxic and flammable, so this entire...
It is critical that the volume remains precise in milliliters, the pressure reading in bars, and the temperature in Celsius. The crimp must be strong enough to seal permanently, but not so strong that it damages the internal components.
We have the positive terminal here, the crimped vent, and the laser-etched serial number. The build quality is excellent. period. The process involves 3 phases: constant current, where the voltage increases, followed by constant voltage, and individual precision multiplied by mass production scale.
We X-ray every single cell to detect internal defects invisible from the outside.
Cells are sorted into grade A for automotive use, grade B for stationary storage, and any defects are sent to recycling.
We collect over 50 data points on every cell, and this data follows the cell throughout its entire life.
Our comprehensive traceability system uses rapid laser pulses to serialize each cell. This cell.
The 4680 is 5 times more energy per cell and 6 times more power, while being simpler to manufacture.
Fewer cells needed per pack, simpler pack construction, lower manufacturing cost per kilowatt hour. We utilize both the 2170 and 4680 formats simultaneously to optimize for the diverse requirements of our.
The trays are designed to maintain cell spacing and prevent contact during transport and storage.
We're starting the day aiming for 142,000 cells. The afternoon shift is performed well above target.
We destructively test a statistical sample to verify internal assembly quality, even though it means destroying perfectly good cells.
These cells will cycle 2,000 times over the next month to validate our 15-year lifespan projections.
Ropers. Here at Industrial Line, we ensure every design passes rigorous safety validation. We conduct crush, nail penetration.
By utilizing this AGV system, we've implemented a true just-in-time manufacturing flow, which significantly minimizes yields.
Cells must be stored in controlled environments to prevent degradation before they're assembled into modules.
To understand how it works, we disassemble the steel case. Inside, you'll find the cathode, anode, and this crucial separator film.
This factory never sleeps. 24 hours a day, 7 days a week, 365.
The batteries made here are powering the electric vehicle revolution and enabling renewable energy storage worldwide.
This tiny cell represents human ingenuity, collaboration across continents, and hope for a cleaner future.
The future is electric, the future is sustainable, and the future is being built right here, right now. One battery.
Every pack has a story, from rocks in the ground to powering real families' daily lives.